Today's industrial supply chains are constantly at risk. Delayed shipments, unexpected machine breakdowns, bottlenecks in production, and transportation disruptions can ripple across the entire network, driving up costs, halting deliveries, and eroding resilience. Now, imagine a system that doesn't just observe these issues, but actively anticipates them, responding in real time to keep operations running smoothly. The NARRATE project aims to build this kind of intelligence, a smart manufacturing network powered by digital twins, AI, and advanced analytics. With NARRATE, industrial partners can detect supplier delays and instantly switch to an alternative, predict equipment failures and schedule preventive maintenance, identify and resolve production slowdowns dynamically, and reroute deliveries when real-world obstacles arise. The goal is clear: build a more resilient, adaptive, and sustainable manufacturing ecosystem. To make this vision work, NARRATE relies on a powerful middle layer, the Blueprints Management System, or BMS. This is where raw industrial data is transformed into structured, contextualized digital twins. Each blueprint, whether it describes a supplier, a product, a process, or a machine, is turned into a smart object that the system can reason over. These digital twins are governed by a shared ontology, a common language that ensures every element of the supply chain is consistently defined, traceable, and semantically rich. This allows the Intelligent Manufacturing Custodian, or IMC, to understand and act on the supply network in real time, not just as a data stream, but as a living, interlinked digital ecosystem. You've seen the big picture. Now, let's zoom in and walk through how we actually build this smart manufacturing system inside the BMS. We'll focus on the most critical steps: creation, deletion, update, and intelligent querying and selection, all supported by our semantic reasoning layer. Every journey begins with a sales order. In our system, a sales order blueprint defines one or more products to be manufactured, with each product represented by its own blueprint. Each product is composed of a number of components. These components can either be manufactured by a lead manufacturer, or supplied directly by a component supplier. We begin by creating the essential blueprints for production. First, a sales order. Each property follows a semantic rule, with defined cardinalities. That is, how many values each field may hold. For example, properties like includes product is defined as one-to-many, meaning this order can carry one or more product. This flexibility is controlled by the ontology, ensuring consistency, validation, and interoperability across the system. Next, we define the lead manufacturer, the primary entity responsible for executing the order. Like the sales order, its structure is semantically defined. Because of this reasoning logic and cardinality enforcement, users are prevented from creating logically inconsistent models. And finally, we create the product or products for the sales order. Our system is powered by a bidirectional semantic reasoner. For example, when the product is created, the reasoner automatically detects the link to the sales order and establishes the relationship, without any manual steps. The BMS uses relationship types and cardinality constraints to validate every connection. These links are semantic, automatic, and self-healing. If one side of a relationship changes or is removed, the system adjusts the inverse relationship too, maintaining structural integrity. To showcase our next functionality, let's assume a supplier is flagged as unreliable, perhaps due to recurrent delays. In response, we can update the supplier's status blueprint, flagging them as either inactive or blacklisted. This change reflects directly in the ontology, enabling downstream systems to automatically exclude or deprioritize the supplier in future procurement and manufacturing decisions. Now consider a deletion scenario, one driven by real life. In our smart manufacturing network, the component EcoVarnish X, a non-toxic varnish used in product finishing, is supplied by Oakline Finishes and referenced in several product blueprints. When Oakline Finishes discontinues this varnish due to rising costs and regulatory shifts, the Blueprints Management System must react to ensure digital twin accuracy. Before deletion, the system identifies and displays all affected blueprints, giving users full traceability of the impact across products, suppliers, and processes. The system then detaches EcoVarnish X from all related product blueprints, removes metadata such as certifications and logistics routes, and flags each affected blueprint for follow-up. This structured and transparent delete operation ensures that every dependency is accounted for, keeping the digital manufacturing model trustworthy and adaptable. Sometimes, the customer wants more control. That's where our advanced querying and comparison features come in. For example, before placing a sales order, users might want to view potential suppliers and filter them based on attributes like supplies material usage, location, has rating, or supplier is certified by. Our fuzzy logic layer even allows flexible matching, adjusting how strictly results are ranked so you can trade precision for practicality. Each result is expandable, giving users a full view of the result's properties, explainable and auditable, all visible in one place. And when you need a clearer picture, switch to the comparison view. All queried suppliers are laid out in a side-by-side table, letting you evaluate them instantly across critical sustainability metrics. You can explore structured properties like carbon footprint, annual water consumption, energy usage, and many more sustainability metrics. And when you want to go deeper, the system generates summary statistics across all suppliers, computing averages and standard deviations. The entire table, including metadata and statistics, can be exported as an Excel report ready for documentation, audits, or collaborative review by procurement, ESG, and compliance teams. This opens the door for integrated analytical models like sustainability scoring, supplier clustering, or carbon risk forecasting, all grounded in real-time semantic data. From order creation to supplier risk handling, from dynamic comparisons to sustainability insights. The BMS is more than middleware. It's the foundation that enables resilient, transparent, and sustainable manufacturing across the NARRATE platform. Thank you for watching, and welcome to the future of intelligent supply networks.